Now, as we looked at solving equations using the quadratic formula, we had solved several of them in the last video. Now, some of them had one rational root, some of them had two rational roots, some of them had two irrational roots, and some had two complex roots. What part of the quadratic formula determined whether it had one rational, two rational, one or two irrational, or two complex? Well, it's really the part that's inside of the root. That's the b squared minus 4ac. That's actually referred to as the discriminant because it lets you know what kind of answers you're going to get. Now, if that b squared minus 4ac was negative, meaning less than 0, that's when we got the two complex roots, the parts that had i's. If that b squared minus 4ac was equal to 0, that's where we had one rational root. Now, if that b squared minus 4ac was greater than 0, that's where we had two roots. Now, if that was a perfect square, it was two rational roots. If that was not a perfect square, we'd take the square root of something that didn't work out nice, so we get square roots in it, and that was two irrational roots. So on these next few problems, we want to use the discriminant here and determine what types of answers we get. Now keep in mind the discriminant's only what's inside of the root, not the root itself, just what's inside. So let's go ahead and use our discriminant here to tell us what kind of answers we get. So we'll go b squared, so 6 squared minus 4 times a times c. Simplify it down, we get 0. So once again, according to this, if we got 0, it's one real rational root. So we get one real rational root. Doing that over here, b squared minus 4ac, simplify it down, we get negative. Oh, while looking at this, if it's negative, meaning less than 0, we get two complex roots. So go ahead and try to do these last two quickly. b squared minus 4ac, we get 64. Oh, that's positive, and it's a perfect square, so we get two real rational roots. Now, when we do this one here, we get 5, which is also positive, but it's not a perfect square, so we get two real irrational roots.